today we're going to talk about two more triangle congruences, angle, side, angle, and side, side, side. So in lesson one, I showed you that a translation and a rotation and a reflection can map two triangles, one to the other, given two congruent sides of the included angle. Well, here we have two congruent angles and the included side. We could translate and rotate to line up the congruent side with the congruent angles. And then if I just reflect C triple prime over line AB, because these two angles are congruent, C triple prime is going to line up with C. So again, the rigid motions will map, if I have angle, side, angle, the rigid motions will map two congruent triangles together. For side, side, side congruence, I can again line up a congruent side. But since I don't know anything about the angles, in theory I can't just reflect over and say that B is going to map to B prime. But what I can do is if I drew an auxiliary line, then I have an isosceles triangle over here, so this angle matches that one, and I have an isosceles triangle over here, so this matches that. Once these angles match, if you were to reflect, that's enough to say that B is going to map to B prime. So because of that, I have another triangle congruent side, side, side. Getting three sides congruent is sufficient to prove that the triangles are congruent. Okay, so we are going to prove using any triangle congruence method that we've discussed. So our triangle congruences are going to be side, angle, side, side, angle, or side, side, side. So if we take a look at this guy, M is going to be the midpoint of HP. So M is in the middle of HP, not necessarily GR. M is the midpoint of HP. And then angle H and angle P are congruent. So here's my given, and I'm going to mark up my diagram based on what I'm given. Angle H is congruent to angle P. So I marked up these sides, but I really need a statement saying that they are congruent. So I'm going to say that HM is congruent to PM. And that is because of the definition of a midpoint. All right, so I have an angle and a side, and now if you look, I have the bow tie looking thing, so I've got vertical angles, and we know that vertical angles are congruent. So I'm going to write my next congruent statement. Angle HMG is congruent to angle PMR. And that's because vertical angles are congruent. All right, well that's sufficient. I have angle, side, angle. That is sufficient to say that the triangles are congruent. So I have triangle GHM is congruent to triangle RPM. And that is because angle, side, angle is congruent to angle, side, angle. Now the second part of this says identify the rigid motions that would map one triangle onto the other. So if you look, if I rotate around M, I can rotate point P around M, and he's going to map to H, and R is going to map to G. So a rotation, capital R, about point M of 180 degrees of triangle MPR is going to map to triangle MHG. All right, so let's look at the next one. I'm given the triangle with some triangles inside of it, and I have AB is congruent to AC, and XB is congruent to XC. And I'm going to prove that AX bisects triangle BAC. Well, think about what it is for an angle to bisect another angle. And basically that means that these two angles have to be congruent. So if I can show that angle BAX is congruent to angle CAX, that's enough to say that AX bisects BAC. If I want to get these angles congruent, then I'm going to try to get these triangles congruent and then use CPCTC. So that's kind of the process for this one. Let me mark up AB is congruent to AC, so we have that. XB is congruent to XC. So I almost have it. Because I have a side, side, side triangle congruence, if I can get AX, this side congruent, then I've got it. And I can because AX is reflexive. So AX is congruent to AX. That's the reflexive property. And that's enough to say the triangles are congruent. Triangle AXB is congruent to triangle AXC. And this time we use our side, side, side congruence. Three sides, corresponding sides of the triangles are congruent, so therefore the triangles themselves are congruent. Once you have the triangle congruent, I can go back and say that angle BAX is congruent to angle CAX. CPCTC, corresponding parts of congruent triangles are congruent. Now that you have that, that meets the definition of an angle bisector. So AX bisects angle BAC. And that is the definition of an angle bisector. So this is an example of how we first got the triangles congruent, and then we use CPCTC to get these angles congruent, and then we use definition of an angle bisector to say that AX bisects BAC. If I wanted to think of the rigid motion that maps ACX to ABX, it looks like it would be a reflection over line AX. So that would be a reflection over AX of triangle CAX, and that's going to map it to triangle BAX. So I'm going to do this next example for your notes, and then the last one we will save for class and do together. This one I have circles with center in A and B, and they intersect at C and D, and I want to prove angle CAB is congruent to angle DAB. So if we take a look at our diagram, angle CAB is congruent to angle DAB. That's what I want to prove. Well, I'm going to have to get the two triangles congruent and then use CPCTC to do that. So let's write down our given. We have circles, we have circle A and B, and they intersect at C and D. That's our given. And then what I like to say is if you have any reflexive or any either vertical angles or reflexive, let's get them down. So I can say that AB is congruent to AB by reflexive. And then we actually have to think about the properties of circles. What do you know about AC and AD? And hopefully you can see that AC and AD are radii from the same circle. The same thing goes with BC and BD. And radii of a circle are all congruent. So what I can say is AC has to be congruent with AD, and BC has to be congruent with BD. Radii of a circle are congruent. So it's this and that. So which triangle congruence is that? Hopefully you can see that that is side, side, side because I have the three sides marked up. So that's enough to say that triangle CAB is congruent with triangle DAB. Side, side, side is congruent with side, side, side. Finally, that's enough to say angle CAB is congruent with angle DAB. Corresponding parts of congruent triangles are congruent. And there you have it. We're going to practice more of these in class. So now we have two more triangle congruencies. We have angle, side, and side, side, side.